Good morning. We are squaring off, we're looking at squares, and we're doing that via angles, basically. I keep deleting everything here. There we go. And so we're going to use our Screencastify here, and I'm going to use the whole screen so that you can see it better. So if you look here at the example on our 5 dot by 5 dot grid, this one little square is 1 square unit. Okay. And then if we go over here to our next square, and I use my drawing tool, and just like we did on the last one, I want to get that down to as small as units as I can. So there's 1, 2, 3, 4. So that's why this is called 4 units squared. Okay, 4 square units. And then down here, it says, you don't have to answer this question, but think about it. What is the area of the largest square on a 5 by 5 dot grid and the smallest square? And you'll be answering that here in just a little bit. How many squares with different areas can you find? And that's part of our sorry, my investigation went somewhere. That's part of our focus question. So part A is I'm going to demonstrate on Screencastify how to answer this question. And it says, using the dot grid, how many different dots can you draw? Okay, so I'm going to go up to the file that I gave you to use. And it's a file this time instead of an assignment. Okay, and we have some of the figures drawn here for you. And now we're going to see how to draw and use this for sorry, lost my train of thought. To actually see how many square units each of them have. All right. So if you look at this one's very obvious. This is 1 unit squared because we're just using 1 unit. Okay. Then we go over here to our next unit, and I'm going to use my I'm going to use my I'm going to go back maybe to my unit, to my drawing here. Well, it's exiting me out here. And I'm going to use this to help me look at I think I'm going to exit out of this real quick and bring it up. I'll leave that on there for you guys, but I'm going to bring it up and not do it actually on the document that I left for you guys. So let me exit out of this. You don't have to do anything on it, but I'm going to actually pull it up on my Google Docs so that I can show you editing to edit, how to edit it. Okay, so if I go back down here to Screencastify, And it says, I'm going to record this tab. Okay, so now I'm learning all kinds of new stuff. So I'm going to 2 units squared, and I'm going to draw maybe here. I'm going to, but again, what you should see, you should do like we did on our last assignment and make a perfect square around it, because it's an irregular figure the way it's turned. It's actually a rhombus. You still have to know those types of figures to help you figure out the area of this. And so if I draw this across here, I know if I move this up here and I move this up here, that's what gets that to 2 units squared, okay? So that's the area of that figure, okay? So now I'm going to 4 units squared. That one's pretty easy because I can just draw my lines again, and I can count the area. 1, 2, 3, 4. It's the area inside, or 2 times 2, which is 4. Okay, so on your paper, it talks about having a diagonal or slanted side. And so 5 and 8. And for 10, those are what it's talking about. So I'm going to save those till the end. I'm going to go to 9 and 16 because those are pretty obvious. So I'm going to draw all of those like this. And I'm going to count to make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there I have 9 units squared. So that justifies it. Or you can take 3 times 3. Ooh, that was squiggly. And again, here, prove that this is 16. Okay, so again, 1, 2, 3, 4. 1, 2, 3, 4. 4 times 4 is 16. Okay, so now let's prove that this is 5, because it's not as easy to see that this is 5 units squared. So I'm going to draw around the outside. And a reminder on finding the area of a triangle. An area of a triangle is base times height divided by 2. Okay, so you need to know that for this problem, because we have 1, 2, 3, 4 triangles. And the area of the triangles, we have the base, which is 2, times the height, which is 1. Okay, so we have 1, 2, 3, 4 of those. Okay, so 4 triangles. So we have base times height, which is 2, divided by 2, which is 1. So the area of the triangles is 4. Okay, and then 1, 2, 3, and then 1, 2, 3, which is 9. So that's the area of the rectangle. So then you subtract those, and 9 minus 4 is 5. That's how we get 5 units squared for that area. Okay, so we have to use the area of the rectangle a lot to find that. Okay. All right, we're going to do the same for, you notice we skip 6 units squared. 6 units squared, as I mentioned, one of the questions, is one of those squares that's not going to be easy to find the area. okay? And you're going to have to think about why. Why is it not easy to find the area of a square that is 6 units, okay? So let's look here. And think about 8 units squared, okay? So we have to do the same thing. We have to find the area of the big square. And I was able to count that one over there because it's very tiny. But we're going to draw the lines here. Getting a little bit better. So I'm going to do 1, 2, 3, 4, 1, 2, 3, 4, and that's 16. It's not because it's 8 times 2, so don't be thinking that that's what it is. So now I have to subtract the sides that are not shaded with the rectangle or with the triangles. So I have 1, so this is either side, it doesn't matter, base times height divided by 2. Okay, so base is 2 and height is 2. So base time 2 times 2 is 4, divided by 2 is 2. Okay, and then we have 4 of those. So 2 times 4, okay, is 8. So I'm going to subtract 8. So I'm going to subtract that. And that's how I get 8 units squared. Okay, that's how I get 8 units squared. All right. Now our number 10. And I'm going to pull up yeah, I'm going to keep this pulled up so that we can look at it. Whoops. Okay. Okay. So 1, 2, 3, 4. 1, 2, 3, 4. This one's going to be 16 as well. It's kind of funny that it's 16, the same as we had before, considering the area is 10 units. But let's look at these triangles. They're different shaped. Okay, so the height is 1 and the base is 3. So 1 times 3 is 3 divided by 2 is 1.5. Okay, so 1.5 times 4, because there's 4 of them. So 5 times 4 is 20. 0, carry my 2. And then 4 times, that's awful, 4 times 1 plus 4 is 6. Put my decimal point. And so I subtract 16 minus 6, which is 10 units squared. Okay. So one of your questions asked you, okay, it's on your last page there, something about for a square of 6 square units to exist. Okay, I'm going to do one, let me pull it up, for 7 square units to exist. And this should give you an example. Sorry, keep going to the wrong place. Oh, it might help if I get my pointer back. Oh, here it is. I had it pulled up already. Okay, so we're looking at trying to find for square, you guys will do those 6 square units. I'm going to demonstrate one for 7. Okay. So in order for it to be the 7 square units, the side of the square has to be the hypotenuse of a triangle whose legs have whole number lengths. Okay, so that's why it doesn't work, because 7 is not a whole number. Okay, so if I go, oh, I can't draw on this one. Yes, I can. Okay. So it has to have whole numbers. So I can't do 7. So I can't do 1, 2, 3, 4. I can't do 7. I can't even do a diagonal. 1, 2, 3, 4. Okay, so in order for that to exist, the whole number lengths, then the sum of the squares of each numbers must be equal to 7. Okay, no 2 numbers exist for that to be equal to 7. So think about that. You're supposed to think about what other one doesn't work. So this would have to be 7 for it to be just like our other examples. For it to be a perfect square, it would have to be 7 length and 7 this way, which it can't work. Again, the reason why it can't work is that for a square of 7 square units to exist, the side of the square has to be the hypotenuse of a triangle. Okay, it has to be the hypotenuse of a triangle. Okay, and I believe that is down here. Yeah, and it says, why are some square areas not possible, like a square with an area of 6? So I just gave you an example of a square with an area of 7. Okay, so that's your hint. If you have issues with that one, if you don't understand, then let me know. Okay, so like 9 would not work either. Okay, so those are some other examples that would not work. And I'm sorry, 9 works. Sorry. 7 would not work. 11 would not work. Okay, so it's because, again, the sum of the square of those numbers must equal whatever the area is squared. Okay, because you have to find the hypotenuse. All right, that's all for today.